All right, welcome to this video on slope. We're going to transition from unit rate, which is a rate of change, into slope, which is a little bit more specific of a type of equation. Okay, so I'm going to kind of start here with some vocabulary and some pictures on the front. So let's look at these ramps. These are skate park ramps. So you got a little skateboard here, okay, and you're going to ride down the ramp. Okay, on each of these. Which one do you think is going to be faster? Okay, it's pretty obvious that that B is going to be faster. Okay, it's steeper. You're going to slide down it faster. So what measurements do they have in common? They have the same height. Okay, these both have the same height. Which measurement is different is the length. Okay, so on skateboard ramp A, you're going to be going a lot longer in length, so you're not going as steep. So which one happens to be more steep? This is ramp B, okay? Slope describes the steepness of a line. So in a linear relationship is graph, the slope is the value described to the steepness of the line, okay? The slope is the ratio of vertical, okay, up and down change compared with the horizontal change, okay? Or sometimes we call this rise and run. Slope is equal to the All right, moving on here. Real quick. So when we're thinking about slope, we also think about another way I like to talk about slope is how much the vertical change is change in y divided by change in x. So what does that connect to that we were just doing in unit rate? With unit rate, we were always dividing y by x. So it really does connect here to what we were learning before. Now, we're going to now use M to represent slope. We use K for unit rate because it's a little bit different, but that's okay. We're going to start to transition here between the two. So slope is a rate of change, just like it is in unit rate, okay? Rate of change. They are both rates, okay? It's how much is the line changing. So this is a positive slope. We always look at graphs from left to right. So if I look at this graph as I'm going to the right, the graph is going up. Here, the next one, as we go to the right, what's happening to my graph? It's going down. Therefore, it has a negative slope. Okay, here, as I go from left to right, there's no change. So we have zero slope. And here, as we go from left to right, it doesn't move at all. It's up and down. We call this is a little bit tricky. You won't see a lot of these. This is undefined slope. All right, so let's look at this example down here. We are going to pick any 2 points on the graph, okay? We look for nice, pretty ones. So I see this one, and I see this one, okay? We are going to draw a triangle to count and I'm going to call this change in y, and the change in x. Okay, so we always go from left to right. So our change in y is vertical change. Our change in x is horizontal change. Okay, they also call this rise. Okay, so change in y, change in x. So this goes up. We simply count the boxes. 1, 2, 3, 4. And it goes to the right 2. Whoops. So it goes up 4. It goes right 2. So our rise, it's going up 4. It's running to the right 2. So our slope is 4 divided by 2, which is equal to 2. So set up this is called a ratio or a fraction. Double check if the graph is positive or negative. So this is a positive line, okay? It's going up and to the right. All right, flip to the next page. Let's look at a couple more examples. So the first thing I ask is this proportional? So no to proportional. So not proportional. Why is it not proportional? It doesn't go through the origin. Okay, is it a linear? Yeah, yes, linear. It's a line. Okay, what is the rate of change? So since it's not proportional, we do not have a k value. There is no k value. We have a slope. Slope is change in y over change in x. Okay, how much does y change versus x change? So we're going to start here on the left. We're going to go down and right. So I'm going to draw in arrows. Down and right. So my vertical change has come down. 1, 2, 3, 4. So my vertical change would be -4. My horizontal change would be, whoops, I wrote that in disappearing ink. -4. Our horizontal change would be 1, 2, 3, 4, 5. So my slope is change in y over change in x. Remember, change in y is vertical, change in x is horizontal. We also call this rise, meaning how far up, and run, meaning how far to the right. So my slope would be -4 over 5. Okay, we're going to do a couple more examples here, and then we will be done. Okay, here we don't have really that many good points, so we kind of got to zoom in and find. I see another really good point here and here. So again, we're going to draw, we're going up first, up or down first, right or left second. We count how far. So this goes up 3 and right 4. So my change in y is 3, my change in x is 4. All right, next example, we got to pick good points. I see a good point there and there. So now I draw a right triangle to connect the dots. So we are going up 1, 2, 3, 4, and right 2. So our slope is 4 divided by 2. We can simplify that to 2 or 2 over 1. All right, next example. Again, we got to pick pretty dots. There's one there and one there. This one is going down. So it's down 4. And then we are going to the right 1. So my slope is -4 over 1. All right. Two more examples. Okay. We are coming down. We are going to the right. So we've come down, looks like 4 units, and we've gone to the right 6 units. So my slope is -4 over 6, which is -2/3. Okay, here, let's do number 4 pretty quickly. Sorry, I've been going very fast here, trying to get this done before 7th period starts during lunch one day. All right, so this one comes down 2, and it goes right 1. So our slope is -2 over 1. And I'm going to try to connect this to the table. So that first point right here, let me re-darken in these points, is -1, 7. Then we have 0, 5. We have 1, 3, 2, 1, and 3, -1. Well, what pattern do we see here? Every one of these is going down by 2. It's getting smaller by 2. And over here, I should have done that in red because I've been using red. Oh, no, that was right. It's been going down 2 everywhere. And then here, it's been going up by 1. That's our change. That's a constant rate of change. That's what makes this slope. All righty. Thank you for watching.